Next, we're going to work with interpreting correlations. So a big mistake that people often make is interpreting correlation as causation. Correlation does not equal causation. So think of this example. Imagine that at a beach, someone did a study and found a correlation between ice cream purchases and sunburn cases, meaning that as ice cream purchases went up, sunburn cases also went up. Could we conclude then that ice cream causes sunburn? And we might think that's pretty ridiculous. Of course, ice cream doesn't cause sunburn, but there is a relationship. And so what could explain the relationship? Well, in this case, a third variable could explain it. The dry, hot, sunny weather both causes people to buy more ice cream and causes more people to go to the beach, so we have increased cases of sunburn. So we could not say, and it would be in fact silly to conclude from this correlation that ice cream causes sunburn or that sunburn causes ice cream. So we have alternate explanations, and we might think about these alternate explanations as, since we're using the word relationship, let's compare it to a relationship between people. Imagine that when Harry and Sally met, they both began to enjoy scary movies. They hadn't done that before, but they started going to a lot of scary movies together and they enjoyed it. Does this mean by default that Harry caused Sally to like scary movies? And we would have to say, no, not necessarily. Who knows? Maybe Sally caused Harry to like scary movies. You know, maybe she was more into it. Or maybe some unknown variable, like some kind of a new friend that loved the scary movies, influenced both Harry and Sally. But to conclude, because there's a correlation, that the direction was automatically Harry influencing Sally, that would be false. That would be inaccurate. It could be, but we couldn't draw that conclusion. So it's the same in a relationship between two variables. It could be bidirectional or third variable. The x variable might cause the y variable to change. The y variable might cause the x variable to change, or some unknown factor might cause both variables to change. So we identify the alternate explanations as first the expected cause effect. This is the relationship we predict. We predict maybe that Harry influences Sally for whatever reason. So that would be x causes y. The reverse cause effect would be the opposite relationship, y causes x. And the third variable effect is that some unknown variable z influences both y and x. All three of these explanations are possible, so we cannot conclude any causal direction. And in this case, we have our ice cream sales again and our sunburn cases, and we see that they're related with a correlation coefficient of 0.34, but we see that the temperature is even more strongly related to each of these variables, and so this is a third variable effect. In our next example, we have a relationship between variable x, participation in fitness program, and variable y, days absent from work due to illness. So it looks like we have a negative relationship. As participation in fitness grows up, days absent from work goes down. So do we conclude that participation in the fitness program causes people to have fewer days absent because they're ill? Well, not necessarily. It may be the case. Or it may be that the reverse is true. The reverse cause effect, that days absent from work due to illness, when those increase, then participation in the fitness program decreases. You're just away too much. So maybe the sickness is causing the declines in participation rather than participation causing declines in illness. Or it could be some other variable, variable z, causing both of these, participation in fitness and having fewer days absent from work. And maybe this is your pre-existing level of health and fitness. If you're healthy to begin with, you're likely to have fewer days absent and maybe more likely to participate in the fitness program. So in headlines, we often see these misinterpretations of correlational designs. This is an actual headline that was based on a correlation. And it says, Facebook causes depression in teenage girls. Now, we don't know for sure that this could be the case because we already know about those alternate explanations. This study was based on a correlation in which they found that there was a relationship, positive relationship, between Facebook use and depression. And remember, positive doesn't mean good. It just means as they both increase in the same direction. As Facebook use increases, depression increases. So let's look at how these alternate explanations might apply. So it could be the expected cause effect that Facebook use X causes depression. Maybe it causes girls to compare themselves unfavorably to others. And so in this case, variable X would cause variable Y. I'm sorry I can't write on my screen as I would like to. So once again, this will be better in the actual setting. But you can picture these in here with the X causing Y effect. But the reverse could also be true. Maybe Y, depression, causes X, Facebook use. So a girl is depressed, she stays home a lot more, and because she's home a lot more, she tends to go on Facebook. Or it could be a third variable. Some unknown factor, like maybe parental neglect, causes these girls both to feel depressed and to go onto Facebook a lot. And you might think of more variables that might be examined for variable Z. So, causal conclusions may not be drawn from correlational findings. Another example is a study that shows that happiness wards off heart disease. And in the first sentence, it says, being happy and staying positive may help ward off heart disease. And what they actually did is just a correlation. They just monitored people's health and monitored their mood, their, say, level of anxiety or positivity. And so they had a correlation. And they found that those people who were happier had lower cases of heart disease. And so they concluded, perhaps falsely in the headline, that being happy caused the decreases in heart disease. So what could it be? If we look at the expected cause effect that was predicted by that headline, we would say that happiness could cause heart health by creating healthy conditions in the body overall. So that's what they're expecting. And it could be. But it's also possible that the reverse is true, that having a healthy heart causes happiness. Maybe people feel relieved to be healthy. When their friends are falling ill, they look around and say, my goodness, I'm very grateful for my health. Or it could be a third variable effect that causes both heart health and and happiness. And that factor might be exercise, so that the more you exercise, the healthier your heart is. That's a likely relationship. And the more you exercise, the happier you are. And there's also evidence for that. So maybe it's exercise that's causing both of these, and it's not actually X causing Y or Y causing X. So once again, causal conclusions may not be drawn from correlational findings. So this last one we'll do in class. I cut this article out of a newspaper, and this was one that showed that listening to music with raunchy sex lyrics causes teens to start having sex. You can see what the headline says. That word prompt suggests a causal relationship. Once again, this was just a survey. They asked teens what kind of music they enjoyed listening to, and then asked them about their participation in sex. And so if we assume that the teens were honest, which just for the sake of this example we will, then can we conclude, as the headline suggests, that listening to raunchy sex lyrics causes teens to have sex? Well, it could be. Maybe. They listen to those lyrics and they get the idea, but maybe not. And so the way that I've teased this out is that the expected cause effect, X could cause Y, Well, sure, raunchy sex lyrics could make kids sexually active. It stimulates their desire. Or the reverse could be true. Maybe being sexually active, variable Y, might cause kids to listen to music with raunchy sex lyrics, variable X, because the lyrics remind them of their sexual experience. Or maybe some third variable, Z we might name it, causes both X and Y. And such a variable might be a peer group. And so if they have a peer group that is listening to raunchy sex lyrics and being sexually active, then that peer group might be the cause of both the music choice and the sexual activity.